So how do we classify these various hazards, be it powder, bacterial, viral? Anytime I go anywhere and somebody asks me, what do I do with this? I can point you to the government guides that are out there. It's always important to work with the in-house EH&S team, biosafety officer, whatever is on campus to help with those resources, because they're really the one that kind of take the bait for what's happening on campus, what they need to use, right? And I think here at my work, I think biosafety cabinets fall under a little bit different realm. So forgive me for that one, but that's typically how that goes. There are 2 biosafety standards out there that a lot of biosafety officers look at for guidance as far as hazard and where they're classified. That would be your BSL 2, 3, 4, it's a BSL 1. This book is called the BMBL. It's put out by the CDC. It's also kind of referred to as the Bio Bible. It talks about how you ventilate labs, what primary engineering controls you need to have, how they need to work, what you need to have in place, all those good things, okay? Talks about different cabinet types, what they do, what they don't do. And then the World Health also has the safety manual. It's very similar. For chemical standards, it's typically, or powder standards, we typically look at NIOSH or OSHA through the CDC for exposure limits, right? So it's not necessarily about, I can't have any of this around. It's about how much of that chemical can be around and what is the occupational exposure limits for that. That's not exactly how we look at biohazards, right? I don't care if it's a little bit of TB or a lot of TB. I don't want to have it around me, right? So it's a little bit different sometimes when you talk about chemical powders. So what happens when people come to us and they say, I need a hood? And then they'll sometimes either say, I get a lot of calls saying I need a fume hood. And it turns out after talking to them, what they need is a biosafety cabinet, or vice versa. They'll say, I need a bio cabinet. Really what they need is a fume hood. So I like to break this down into 3 simple questions to kind of get to the root of where we need to go. The first question is, what type of protection do you need, right? A lot of people think a hood always protects people. That's not necessarily the case. There are enclosures out there that provide product protection only, that don't protect the people. And you might say, well, why would I need that? We'll get to that in a minute. But do you need to protect the product? Do you need to protect the person or the environment or all 3? What's going on here? What are you protecting from? Do you have fumes? Do you have vapors, powders, biohazards, airborne contaminants? What are you working with? What is your, and sometimes they're like, well, I have this piece of equipment. Okay, well, what's that piece of equipment going to put out? What is its risk? What is it, why do you not want it on a bench top? It's basically what we're asking people at this point is, why do you want to put this in something instead of letting it sit out on the bench? So what you're trying to find out what they're doing. And the last are, what are the application requirements? Are you going to put something in here that makes a lot of heat? Do you need a lot of tubes and hosing and service fixtures and all those kind of good things that we can put into different enclosures? What process are you doing? Does somebody need to sit at this all day versus just walk up to it for 5 minutes? What all do we have to consider in this enclosure and how it's going to be used? So how do we control hazards with airflow? And I apologize if this is very basic for some people, but it kind of gets into, I like to think about which way the wind blows, right? And because my products do a lot of different things. It's not just about protecting people, right? So I think of the blower in any system, be it on the roof, in the cabinet, wherever it is, you have 2 sides of that blower. You have negative pressure, and you have positive pressure. It's either pushing stuff out the roof or it's pushing stuff down into the enclosure, right? The negative pressure side is going to pull air through it. The positive pressure side is going to push air through it. So what happens if in this situation, when I'm trying to control my hazards, whatever I'm working with, if I have the enclosure on the right side here, then I have my fan, and then I have my HEPA filter, right? So I'm going to be pulling air in from this way, pushing it through that HEPA filter and pushing it out the other side. So basically what I have here, this is going to provide me personnel protection, right? It's pulling room air in the front, pushing it through that HEPA filter, nice clean air comes out on the other side. What if we flip that? And why would we want to? Believe it or not, it happens. So what happens if I have my fan, but I have my HEPA filter here? my enclosure here. So my negative pressure side is pulling air, room air through this filter and then pushing it out the front, right? Then I have an enclosure that takes this room air, pushes it through and out the front of the enclosure. This gives me product protection, not personnel protection, but what I end up with inside this enclosure is a nice, clean environment, right? It doesn't have any airborne contaminants, doesn't have anything in it. This is kind of like what we do in our house, if you think about it, if you have a HEPA filter, right? That's what you're doing. You're just cleaning the air, it's pushing it back in, but we're going to push it into a box where we can then have a nice, clean work area. And that's how we get what we call a clean bench. Sometimes they're also called laminar flow workstations or laminar flow benches. Another thing you'll learn about all these laboratory hoods is everybody has a different name for them, which is why it's a really good idea to find out what they're doing. So this type of clean bench enclosure typically comes in two formats. You have a horizontal clean bench where room air is coming in the front, being pushed through the HEPA filter, and you have a wide open face. This is great. I can walk up there. I can work. You find these in pharmacies. I don't know. Is there a vet pharmacy on campus? Compounding vet pharmacy? If there is, they will use these to compound non-hazardous medications. Sometimes you can use a vertical as well. They typically like the horizontal. These are great for plant research, right? Because a lot of times my plant seedlings, they're not harmful. They're not going to hurt me, but I don't want any dust or mold or bacteria in the air getting into my soil or my media, right, to contaminate them. And then we have vertical clean benches. Again, room air comes in the top, the blower pulls it through, pushes it through a HEPA filter, and you have this nice, clean, what we call ISO 5 environment or sterile environment. Kind of like, this is what our horizontal clean bench looks like. So you see somebody in there working with some plants. Important thing to remember about laminar flow benches or clean benches is they are only protecting the product, no hazardous work. These are positive pressure enclosures. They're blowing whatever you're working with right in your face, right? So nothing hazardous on these ever. They provide inside the enclosure what we call an ISO 5 work environment or better. That's considered kind of a sterile work environment. Common applications, plant. I'm sure you guys have these on campus in some plant labs somewhere, as well as PCR enclosures, if you've heard of that application. A lot of media prep can be done because cell culture media, things like that aren't hazardous. You might not want your biosafety cabinet time being taken up by something that just needs a clean bench, so it can save time on other hoods. They're also used in some electronics labs just to keep dust and things away from the sensitive components while they're packaging them up. And then in non-hazardous sterile compounding. So if you have a vet compounding pharmacy, you'll find these in that lab as well. Any questions on clean benches before I jump in to the other type of enclosure? We're also going to be around afterwards for questions, so feel free to come up to us and ask any questions. All right, so what happens if we flip that fan the other way? And now we're going to start taking the air, moving it instead of down through the top and out, making that clean environment. We're going to start cleaning the environment that's in the enclosure with that HEPA filter and sending the air out the top of the unit. Okay. This type of enclosure, negative pressure, personnel protection only, and this is where you'd want to have your hazardous powders and your hazardous particulates. Okay? They do not protect whatever they're working with from contamination because it's just room air coming in, and room air has all kinds of good stuff in it. Okay, so it's not going to protect them from that. Common applications are anybody that are weighing powders. So sometimes you'll find these that are called balance enclosures. Anybody that's milling, sometimes if they're milling up or grinding up powders, or like an old school mortar and pestle if they're grinding things down. Sometimes, again, in veterinary science, you find this because pills are all different sizes and you need to dose out powdered medications separately. Equipment housing. How many 3D printers are on this campus? Does anybody know? Yeah, so there was just a fun report that I'm sure you guys know of that came out about 3D printers and what all they put off into the world we live in. This is the type of enclosure for that, right? This is going to trap those smaller particulates. We talked about HEPA filters. We also have what are called ULPA filters, which are like super HEPA filters. We can put those in this enclosure as well to get, trap those really fine nanoparticles better. Okay. And then again, hazardous non-sterile compounding you might find in your vet med pharmacies, this type of enclosure. This is what it looks like when you take some smoke to the inside of the unit. The air is coming in the front, carrying everything in the back, and then the HEPA filters up across the top. When you want an enclosure like this, what should you be asking? What questions should you ask? What should you be looking for? Again, go back, ask them what they're doing with it. Are they putting a scale in it? Well, you want to make sure that hood's balanced right to have an ultra balance in it, because if that hood vibrates a lot, your scale is going to be useless, right? It's going to have all kinds of tolerance issues. So balance enclosures should be able to tell you they're suitable up to a 5 or 7 place ultra balance. Another thing you will have with these enclosures, they're a little bit different than, say, fume hoods and even biosafety cabinets, is that, like we mentioned earlier, how OSHA and NIOSH put out the occupational exposure limits for powders. If I'm wearing something like, I don't know, we use naproxen sodium to test these. So that's not super harmful, right? We take it when we have a headache. Versus another powder, like say when we put these in crime labs and they're weighing out fentanyl that they've picked up. So 2 very different exposure limits, right? Any kind of containment hood you buy, a VBE or whatever they're called, you should be able to get from the manufacturer some type of third-party testing. Now, it is a little bit different. We went through Trinity or SafeBridge. Now they're called Trinity Consultants. Usually what they do in these type of processes is they'll have 3 different people weigh. They've got little sensors around the room and around the person to see how much is getting out. As you can imagine, weighing is some people are really good at it and some people are really messy at it. You know, think about a cook in a kitchen. Some people use every pan, some people only use one. So if you don't have good technique at weighing, you can cause a lot more powder to come out of that enclosure than someone that does. So that's kind of a variance that plays in as well. So look for that on your enclosures, see what kind of containment they have. If you have a certain super toxic drug, you might need to move to a glove box. Like this might not be enough for you. So you just want to check that. Things to think about when you're weighing powders. We have these enclosures that have ULPA filters in them for basically the nano world. We've had them for a long time. They do a little bit different kind of particulate containment. I lose my voice talking this loud. But just remember that different particles, different things, the reason I want to say that, aren't always measured the same way, right? There's different ways to measure things. If we just did our traditional particle containment on nanoparticles, some of those sensors aren't even sensitive enough to pick up that small of a particle. So we switched over to something else to make sure that we get that containment. Just ask your manufacturers, what do they have? Again, all of these are kind of in a test facility, but it gives you a good idea of what it can do for you for what you're working with. So, and then I would like to say it's critical to evaluate the performance of these once it's installed. And how that is, or how your validation methods are, what you're doing really comes down to a risk assessment, right? Again, if you have somebody weighing naproxen sodium in a lab or, salt or whatever, and they're just trying to keep it out of the air, that's going to be a different validation performance than what we're going to do with somebody that's in a crime lab weighing fentanyl, right? They're also going to have different training to handle those different chemicals, right? So all of this comes into play. A lot of times we use smoke as one of the easiest, best ways to test containment of something. Because I can give you the best enclosure in the world, and I think we make some really good ones at Labconco. I can say that. But if I walk into that lab and you have a supply air vent right above it, it's just dumping air across the front, it can pull things back out. Right? So even though I know this works, you got to think about placement in rooms. Is it by a doorway? Is it all these other things that can affect that? And some smoke tests, once you get equipment in there and everything else they're doing, is a great way to look at which way is the wind blowing, right? Is it coming back out? Is it all going in? Great way to test them. A lot of people have also started with 3D printers and things using particulate counters around the room. So if you think that's something that you need, you can do that as well. All hoods have different ways of testing them, right? There's all kinds of them out there. Design considerations for this type of enclosure that you should think about. All of our HEPA filtered products that are made for powder or particulate have what's called a bag in, bag out HEPA filter. Why would we need this? Anybody ever change their furnace filter? Little different situation, not what you're going to see when you look at these HEPA filters. But this makes sure that when this HEPA filter is changed, that can be anywhere from 3 years to 10, 12 years after it was installed, that it goes into a bag, it's sealed off. It's just nothing's going to come out of it. So kind of a protective measure for the lab and the certifier that's doing the HEPA filter change at that point. Material of construction. What's it made out of? Is it made out of acrylic? Is that going to stand up to my cleaners that I'm going to use? Is it going to cause static? Some enclosures that are, made out of acrylic or plastic, if you ever think of static around here in the wintertime, right? And I know my hair is always coming out the door. If I'm trying to weigh a powder and I have a lot of static in my enclosure, it's just going to stick to the sides of it, right? So materials of construction can really play into how well the unit stands up over time. We make everything at Labconco out of glass and metal so they can be easily cleaned. They will withstand harsh cleaners for years. They can stand up to that type of stuff. I can't see a clock in here. Oh, okay. All right, up next, biosafety cabinets. Now I know, did anybody in here deal with biosafety cabinets? A couple of you, okay, but not everyone. This is where I spend most of my time in the biosafety world. So I'll kind of keep this as a simple explanation for you. But there are several types of biosafety cabinets. There's 3 classes, and then those classes, the class 2, are divided into types. So it can get kind of confusing. Does this one down here look familiar to anybody? We were just talking about it, right? A powder enclosure. It draws air in the front, pushes air through a HEPA filter. This is considered also a class 1 BSC when it has a certain airflow, okay? So that those powder containment hoods can also be considered class 1 BSCs. Our class 1 unit is a little different in that we don't have that bag in, bag out HEPA filter. So you don't necessarily need it in a bio process because we can decontaminate biological safety cabinets. You can't decon a powder, right? You can't really inactivate them the same way you can a hood that I can go in there and run some decon gas through it and know everything's good. So we don't have a bag in, bag out on this unit. Class 2 BSCs. So this one's protecting the person only. So let's say I'm working with a biological sample that's hazardous. We see these a lot for people that are working in like clinical labs or anything like that are working with stool samples or things like that, where I'm not worried about it getting contaminated, but I also don't want to have any of that come back my way. Class 2 BSCs basically take the 2 types of enclosures we've talked about and put them together. All right, so a class 2 BSC, it's basically a powder hood in a way and a clean bench put in one. So we have personnel protection from the airflow coming in the front. We also have 2 HEPA filters though. We have an exhaust HEPA filter that protects the air going out the top, but we have a supply HEPA filter as well. So some of that air comes down and provides me a nice, clean ISO 5 environment inside the hood. Okay. And then there's class 3 biosafety cabinets, which are very specifically designed glove boxes. Not every glove box is a class 3 biosafety cabinet, and that's very critical. Just because you have a glove box on campus does not mean it's a class 3 BSC. There's many types of glove boxes as well. Okay. So what are the types? What's a class 1 do? Class 1 protects me and the environment from any biohazards. Class 2, person, product, environment. So we get all the levels of protection. Okay. This is what airflow in a class 2 looks like. Again, like I told you, we like to use smoke a lot so you can visualize airflow. Inflow in the front and from up here is all going to come right into the front air grill and it goes under the work surface. We can't have this inlet air going inside the cabinet because then we would contaminate everything, right? So it goes under the work surface. Inside the hood, we have this laminar downflow air, right? That's all HEPA filtered ISO 5 air that's going to protect my samples from any kind of contamination. When are these used? I would say most biosafety cabinets are used for cell and tissue culture. Transfections, you have cell lines, you have animal cell lines, you have cancer cell lines, you're treating them, you're doing different things with them. All that work is done, usually in a biosafety cabinet, right? Protects me, keeps my stuff clean. They're also used in compounding pharmacies. In that type of environment, these are often called chemo hoods, and they're usually exhausted. How do we know they work? What standards do we build to? All that stuff. Biosafety cabinets have a very strict design standard, right? And that comes from NSF International through NSF Standard 49, NSF ANSI Standard 49. They tell us how they have to work. They tell us what the face velocity has to be. They tell us everything. It's not like a fume hood where I can come in here on a class 2 BSc and say, I want to lower the face velocity a little bit. That does not work, right? They have a very strict 100, 105 feet per minute face velocity. How do we know when we need to use them? Again, this BMBL book will tell you class 1, class 2, class A2, class B2, all of that kind of stuff when they need to be used. This is what they typically look like. Most of them are operated from a seating position. The reason for that is when a worker comes up to a biosafety cabinet, unlike a fume hood, they're going to probably be there for a while. When I used to work in one of these, I was there for about 3.5 hours at each stint. So I don't want to stand at a fume hood the whole time. So ergonomics can play a big role in how these cabinets are designed, right? Because they're there for comfort. And I take ergonomics a little further because to me, it's safety. If I'm uncomfortable or something's not right, I'm more likely to mess up and make a mistake. And you can take the best biosafety cabinet in the world, but if I'm working in there and all of a sudden I'm tired and I do this and stick my hands back in, I've just contaminated myself, right? So we want to make sure people stay comfortable. Inside these BSCs, you have a blower, you have a shared plenum, and then you have your HEPA filters. These are typically or should only be worked on by trained certifiers. Reason for that is you never want to go up to a biosafety cabinet and see this. If you see this in an open room and that BSC hasn't been decontaminated, this is a contaminated plenum, right? We've got cabinets out there, I like to say, that are old enough to drink. They're over 20 years old. You have no idea what could be in those filters or cabinets over the last 20 years, right? So you always want to call in a certifier, have those hoods decontaminated before any work is done on the internal plenum components of that. Very important. Okay. So I like to call this little portion of the talk the ABCs of BSCs. Because for class 2 BSCs, you have an A2, you have A's, you have B's, and you have C type cabinets, okay? So we talked about the 3 types, the personnel protection, the one that does both, and the glove box, that's the class 3. Within the class 2, which is the most common class you will find across any campus, there's going to be a class 2 type A2, you might find a B1, you might find a B2, and you might find a C1, and these all operate very differently. Main question to ask, and what do I have, what do I need, is are fuming chemicals being used? Because all these different cabinets exhaust in a different way. So that's where we get into the building maintenance and those applications of these different hoods. If they're using chemicals, how much are they using? So that's the next question for the safety officer to be asking on their risk assessment. Do they have, 1 mil of chemical A is not equal to 1 mil of chemical B. I could have 1 mil of a 1% solvent over here, or 1 mil of chloroform. Those are 2 very different hazards, 2 very different risks. Okay. So how that exhaust air is handled and the design of the exhaust system becomes very important in these. Okay. There are all types. These are all biosafety cabinets, all different exhaust air patterns. Okay. And I'm going to quickly go through them. Class 2 type A2. This is the most common type of biosafety cabinet. They typically exhaust back to the room. This is what you will find in cell culture labs or places like that across your campus, right? Basically big HEPA filtered units that are just recirculating air back to the room. Okay? They provide personnel and product protection, but you cannot use any hazardous or volatile vapor chemicals in here, right? Because they're recirculating air right back to the room, and HEPA filters don't trap fumes. Okay? So what if you have chemical vapors and you have these on your campus? What do you do? What do you do for those people? What we do is we add a canopy to the top. Whoever made your BSC needs to provide the canopy. Do not make a canopy in-house. They will not pass certification. NSF, that standard that told us how cabinets have to work, so you have to have an alarm tied into that cabinet that knows when you have an exhaust failure or anything like that. Because first and foremost, an A2 biosafety cabinet is made to maintain biocontainment. If I have an exhaust failure in the building, that air is going to come back out this canopy into the lab because its core function per NSF is to maintain biocontainment, right? That is its first and foremost goal. So if you have, this is how we start to think about that chemical use and volumes and what is it and how we do our risk assessment, right? So this would be for, very small amounts of any kind of chemical. Small, again, relative, depending on the chemical use. We really have to start asking those questions. What are they doing? How is this working? Okay. A2 style cabinets also have this kind of recirculation loop in them. All the air that comes in is not going out the top. Some of it gets passed back through and is in this loop, right? So if I have something that's flammable or anything like that, one of the things to consider is your amount. Is it possible you could reach your lower explosive limit? It just depends on your volume and what's going on and what's happening there. So these are just all kind of risk assessment things that have to be considered. Okay. Pros of the A2, very common cabinet used in a lot of cell culture work, very solid cabinet. Can be manifolded and exhausted on a general, your general lab exhaust system. Works well with other cabinets. However, it's that small volume of chemical work, right? So just have to remember that. There's no flexibility. I can't turn this into a fully exhausted cabinet. It doesn't work that way. Once an A is always an A. You can put a canopy on, but you're never going to be able to really safely work with large volume of chemicals. Okay, there's a type B1 cabinet out there. You find these sometimes, you might see them on your campus. So what happens when I have more chemicals? I need to really exhaust all the air out of my cabinet, right? I don't want any recirculating. So a type B1, and again, these are not super common, but you may have them. Remember that laminar downflow picture I showed of that smoke coming down and some went to the front and some went to the back? In a B1 style cabinet, all the area you see in red here is 100% exhaust out the building. The front area here, this air is recirculated through the cabinet. Okay. A B2 style cabinet, anybody heard of those? Do you have any of those on campus? Anybody knows? These are more like, and I use this word very loosely. It does not mean it is, but they operate more like a fume hood, meaning that all the air that comes in the front is 100% exhaust out. All the air that comes in the top that comes down over my process, 100% exhaust out. Okay, so there's no air recirculation within this cabinet. Again, this is primarily designed for those larger volumes of chemicals. All right. But these cabinets are also notoriously tricky to get to run, especially if you have several of them and you want to put them all on the same exhaust system, because that's what everybody wants to do because it makes it easier. However, they will trip alarms. There's all kinds of issues. All the standards out there for lab ventilation standards say these should have their own exhaust, their own blower, each unit. Okay. They're tricky to get kind of linked up together. The reason is one of the things we haven't talked about really, but over time, these HEPA filters are going to load, right? With dust and stuff. That means that blower is going to have to work harder. Static pressure is a lot higher. So if I have 4 cabinets on one system, most people prefer to use that one down there because it's like by the window where I can look outside. That one's going to load faster, right? What are these other going to do? They're all pulling the same volume of air. You're going to start getting alarms, all kinds of issues where over time they're going to go out of balance. There's a thing with these cabinets too, that there's alarms that trip within a few seconds if there's exhaust issue detection. So if your valves aren't fast enough, people are like, oh, we'll use Venturi valves. They fix everything. They're not responsive enough or quick enough. You're still going to have cabinets alarming. Somebody opens a sash on another one. If your Venturi valve isn't fast enough, this cabinet that's been happy and running is going to start alarming as well. So B2s have some issues. The other issue with this cabinet is that it 100% relies on that remote blower to function. If my remote blower fails, what's going to happen inside my cabinet? I have a fan in here pushing air down, right? So this fan has to be interlocked with your exhaust alarms as well. So if a vacuum loss is detected, this fan quickly shuts down because we don't want to blow this air out the front, right? So we don't want that to happen. So that's why they say B2s should also have a redundant blower in place should one fail. Okay. These exhaust recommendations come from NSF ANSI Standard 49. That's the one that governs biosafety cabinets, and CETA as well. And I think ANSI Z9 also has some exhaust regulations specifically for how B2s are handled. So just be aware of those if you're looking for some guidance on what to do or how to make them work. So the pros of this type of cabinet are it can handle a large volume of chemicals. Not all chemicals. Remember, these are stainless steel cabinets. Nobody's handling any strong acids in this cabinet. Again, they're probably working with cells, right? Which are not going to tolerate any of that. So most of the things that are worked with in these hoods are solvents, phenol chloroform for molecular biology use, things like that. Okay, so it's kind of where we're going there. The last cabinet is the type C1, and it's fairly new to the market. It was released about 10, 12 years ago, maybe. And it's kind of, you got to remember these cabinets, when they come into your lab, they're going to be there, at least ours are, for a long time, right? 20 plus years probably. How many people have seen investigators move in or out of labs in 20 years? Change spaces, change their work, do something different? If you put a B2 cabinet in a lab, what happens if the next person comes in and doesn't need to exhaust it? You can't turn it into an A2. It doesn't work that way. And then same with an A2, you can't turn it into a B2 if somebody comes along that wants to use larger chemicals. So the C1 is kind of took both of those issues, took some of the exhaust issues, took all the problems that we were having between A's and B's getting along, and made a cabinet that kind of satisfied a lot of those issues. Okay, so basically it's a cabinet that can work in two modes, A or B, right? A mode is your recirculating general lab use mode, no chemicals. B mode means I hook it up to exhaust, I retune the fans in it, have it certified, and I can get it exhausted out of the building, right? For somebody that comes along and wants to work with more chemicals. The central area of this cabinet that you see in red is 100% exhaust. So that's where you know to work with your chemicals. And this is a dished work surface. The outer edge of the cabinets recirculate, kind of like an A. Right, so this also cuts our exhaust volumes dramatically from that of a B2. Great for old buildings, old places that have a bunch of older mechanical systems, right? They don't require as much airflow. Another nice thing is if this cabinet detects an exhaust failure, it's going to ramp up its exhaust blower inside and push air through that ductwork and tell the user, cap up your chemicals, you have a problem. So it gives them up to 5 minutes to get their things kind of cleaned up and capped up and done. And you can set that timer for however long you want, up to 5 minutes. But it gives them that warning. Get your bio stuff closed, get your fuming chemicals closed, get cleaned up, you know, before you're going to have an issue. So it helps with that safety issue as well. This is kind of what the internal plenum looks like. You actually have two blowers in this cabinet, an exhaust and a supply. So to recap on those cabinets, we have the A2, which is the most common. That's going to recirculate to the lab. If they have a small amount of chemicals, you can put a manufacturer-made canopy on top of it to exhaust it out. B2s are 100% exhaust. They can be tricky to get work on mechanical systems, especially if you try and join them up together. And then there's the C1, which can kind of, in between moving them around or changing applications, you can recertify them and either hook them up to a general lab exhaust. They play well with others on a general lab exhaust system as well. So kind of comes up with some of those problems, that limitations that the A's and the B's have. Last thing I had to talk about was the class 3 biosafety cabinet. And really what I want to tell you about this type of cabinet, they're not near as strict on what all components they must have per NSF, like a class 2, but not all glove boxes are class 3 biosafety cabinets. They often have a dunk tank or a sterilization chamber hooked to them. They have dual exhaust HEPA filters, some other things involved. So just because you see a glove box on your campus, don't assume that's a class 3 biosafety cabinet. Okay. For large equipment, there's other types of large enclosures made. A lot of vivariums here on campus. I'm sure those are the people that work with the mice and the rats and the rabbits and the other good things. They have a lot of different HEPA filtered enclosures to work with those animals. All right. Does not mean they are all class 2 rated biosafety cabinets. Cage changing stations and bedding dump stations are HEPA filtered. They'll get a lot of the particulate stuff, protect the workers in the vivariums from any exposure to dander, animal hair, all of that, those types of things. And they do have HEPA filtered downflow air and HEPA filtered exhaust. They're often open on all sides, so they're not going to contain as well as, say, a biosafety cabinet. So why they're great for general cage chaining operations, assuming those animals can be changed in that type of cage, they are not considered class 2 biosafety units. Okay. That's all I've got for today. Any questions? Okay, so the question, just so everyone online can hear, was about pre-filters. Some enclosure types, you can put a pre-filter in them to help extend the life of your HEPA filter. Depends on the type of enclosure, is what I'll have to say on that one. For the clean benches, where they're pulling room air through the HEPA and then pushing it out the front, all those always have a pre-filter, right? Anytime you're pulling room air in that side of it, because they're easy to change out the top. Biosafety cabinets can have a filter that sits under the work surface, mostly to protect against animal bedding and large things like that from getting sucked up into the HEPA filter as well. Powder containment is a little different, especially if those powders are hazardous, because your pre-filter is going to have to sit downstream of your powders. So if that's a hazardous powder, you're probably not wanting to pull out this pre-filter and just change it, right? So those are a little bit different. There are some pre-filters that exist for those enclosures, depending on what you're working with. Again, risk assessment involved for those. But yes, a lot of these do have various types of pre-filters for them. All of our HEPA filters on all of these enclosures I talked about, especially biosafety cabinets, need to be 100% leak tight. So part of the annual certification that's recommended, they take literally a probe across every inch of that HEPA filter, make sure there's no leaks. You go around it. These enclosures, most of them are designed with a negative pressure plenum. So if something does happen to the plenum, it's going to get sucked back in. But again, usually certification companies that have the equipment to do those helium leak tests or the particulate leak tests on the HEPA filters are changing these HEPAs. I would definitely recommend that. And they have some very specific leak testing equipment for that as well. Smoke's great for the front of the enclosure to make sure air is going where it should, and you don't have any like doorways or anything affecting airflow into the front. But you should definitely do a particulate check on the HEPA filters when they're installed or changed.